Good morning, Europe, and good afternoon, Asia Pacific. Welcome to our webinar. We'll be continuing in our series of 5-axis simultaneous given by Ahmad Ankar. But before we start, I'd like to again remind everybody that in just a few moments, just 2 months from now, even just under that, we will be having our SolidCAM World 2018 in Tübingen, Germany. So everyone please sign up for it. All the information is on our website for signing up. Hotel information is included as well. So sign up also for your hotels as soon as you can. We have some hotels listed in here that we worked out a nice price for the rooms, but you have to register as soon as possible. I don't think they'll hold those prices forever. We have a full agenda, as I've mentioned before, so please sign up as soon as you can. All right, Ahmad, we will make you presenter, and you can go ahead and start.
Thank you very much, Sydney. Hello, everyone, and welcome to our series number 6 of 5-axis webinar. Before I begin with today's part and today's technology, there was a question that was asked last time, and I forgot to answer it, and the session was closed. Somebody had asked me about the 3D compensation on what tools are supported for 3D compensation. Okay, there are 2 types of tools that will be supported for 3D compensation. One is a ball nose tool, and the other one is a bull nose tool. We do not support 3D compensation for flattened mills. Okay, I hope that answers your question. All right. So today we are going to move into another very important technology, which is swathing. And swathing basically is to machine surfaces that are almost straight or have a very large radius, and you would like to cut them in with the side of the tool, with the flank of the tool in one pass. Sometimes it's possible to do it in one pass. Sometimes it's not possible to do it in one pass. That's because you have a tool that has a cutting length less than the flank, the total height that you need to cut on that surface. In that case, you need to go with multiple depths. You can't go with a single pass. But the whole idea of swath is to use just the side of the tool and finish the surface in just one single pass. The advantages are plenty. Number one, your part gets finished much faster. Number two, you can get a much better surface quality because you're using the side flank of the tool. Okay, so time and quality are 2 main advantages with swathing technology. Okay, we're going to see this part. In fact, this part is also available on our website. You can download this, and it has got the entire document attached to it, which takes you right from roughing to finishing and swathing. So we are going to add a swathing operation. Okay. So in swathing, like our regular 5-axis, generic 5-axis, we need to define our part surfaces. Now, the difference between a generic 5-axis where we use a parallel to curve or parallel to surface and generate a single line, a tool path, and swath is that in swathing, we do not directly use the surface as they are for calculation. We generate triangulation. Now, there are major advantages using triangulation. The biggest advantage is that in triangulation, you get a very reliable result every time you machine a triangulated model. But with a surface, if there are some issues with the surface, if there are deformities with the surface, you can end up trying to do several iterations before you end up getting a pretty good result. So the first thing with swathing, it works on triangulation. Second, it's very fast. The calculation is pretty fast. And the number of parameters that you need to define and give as an input in swathing is pretty less. So what we're going to do is we're going to machine few pockets and see different technologies of swarfing. Okay, so let's pick swarf. And now it's asking me to define the main faces. So I'm going to make a main faces 1. I'll pick the surfaces which need to be machined. So my surfaces are these surfaces. Okay. These are my surfaces to swarf. Now you have a choice. The choice is you can either, let's make new, let's pick 1, 2, 3, sorry. Let's pick the surface again. This one on this one. Okay. The choice is that you may or may not define the flow surfaces. Now it depends. For example, if you're machining a pocket like this, then it becomes absolutely compulsory for you to define your flow surfaces. Otherwise, the tool will think that there's nothing below here and it will actually move below the surface, especially if you're using a bullnose or a ball-nose tool. The end of the radius will come to the exact edge end, so that you will end up gouging the bottom surface. But if you want to cut the outer surface here, these surfaces, then you don't need to define a bottom or a floor surface, because you anyway are going to break open the surface below, so you don't need to define the floor surfaces. But in our case, we definitely need to define our floor surfaces. So what is included in the floor surfaces is, this is a question people always ask. What is actually a floor surface? Is it only the flat surface or the base surface? Actually, in swarfing, anything that does not include the straight flanked surfaces is to be assumed to be a floor surface, which includes the bottom face and the fillets. The fillets are considered as a floor surface. They are not considered to be part of the swarfing surface, which is pretty obvious because you don't swarf a fillet. Okay, you either achieve the fillet using your tool radius, or you generate another program to cut only the fillet. All right. So I've defined my floor, I've defined my swarf, and then let's touch upon this topic out here, what we call as the strategy. In strategy, many a times you will see that by default, it'll always be set to automatic. Okay, now what is automatic? Let's open Paint. If I have a surface, this one, okay, and I'm trying to swarf the surface. Now I'm looking from the side view here. I have the tool, and if I'm trying to swarf the surface, what SolidCAM will try and do is, it will try to make equal number of points on the upper curve and the lower curve, and it will try and make the tool touch like a line contact on the surface. Now, many a times, this surface is never straight. Okay, practically this surface is never straight. It could be a NURB surface with some twist and other things. Even in that case, the software tries to find the best possible fitting line solution for controlling the tool axis for machining that surface. So this is what basically automatic does. Now, there's another possibility. I have a surface that is like this. Okay. In that case, the points here will be distributed again. Okay. Now, assume that you get one point here and the other point, the corresponding point is out here. So the next option in our strategy is the shortest distance, which basically will join the point using the shortest distance. Now, this, instead of joining it this way, the shorter distance would be this way. Okay, this is the shortest distance. So it will ignore this point and it will come to this point, because this point to this point is the shortest distance. So The tool axis is actually being controlled by the strategies. Whatever the strategy is basically defining our tool axis. So what we're going to do is we're going to keep it automatic and see what the result looks on the machine. Okay, it's very important not to just look at in the host CAD, but also to take it into the machine simulation to understand what is happening on the machine. The tool I'm going to use today is a taper ball nose, a 12 with a corner tooltip radius of 3 and a taper angle of 3 degrees. Okay, so I'm going to use that particular tool. Levels, you can either use this default settings or you could change it. This is explained in our generic 5-axis help. I don't have to again touch this. If you go into the advanced, you can actually do some arc fitting, especially if you're doing a lot of passes. It's not a single pass, but it's multi-passes. In that case, if you generate a lot of retracts, then those retracts can be made smoother by developing or putting arcs or fitting arcs there. In our case, we are going to do just only one pass, so we don't need the arc fit. Let's go to the tool path parameters. Okay, now in tool path parameters, the first thing is the surface quality. We all know what it is. We don't need to. I don't need to again explain to you what a cut tolerance is and what are maximum distances. But what is important here is that the start point. Okay, you can decide where you want the start point to be. Now, if I say automatic, the software will try to find the best possible point to start the cutting from. If I pick exact, it will check for the surface selection that has been done, and it will go to the end of the very first surface that was selected and start exactly from that particular area, from that particular point. And then you have 2 points where you can specify the lower point and the upper point. So it finds out where is the start point and it will start from that particular point with that particular tilt. And then we can define a tilt line and say that this is the place from where I would like to start. I have an edge and I would like to start only from that edge. Or you could say, I just want to start from this point. The tool axis is being defined or decided by the software. Let's use automatic and see where it generates it. The other important thing you need to understand is that when you're machining or doing a swarf, you're actually selecting only a surface. Okay. Now, a surface can have 2 directions. If I pick a surface, this surface could have a direction in this way, or it could be pointing on the other way. So the software needs to understand which side of that surface do you want to machine. Now, the side can be defined using several techniques. One of them is auto detect. Okay, the software will try and find out which side is it trying to machine. Generally, auto detect works well when you have a closed kind of a geometry where you're closing it from all sides. So now it understands from which side to actually machine it. But the best way to always use swarfing is never to use auto detect, but to always to use surface normal. Okay, because we know our surface normals are right. So the direction that is pointing outwards will be picked up by the software, and that side will be machined using swarfing. Direction is climb, and it's one way because you're going to have only one pass. So it's obviously you're going to have a one-way cutting. Now, there is an option to guide the tool either at the lower curve or the upper curve. But we have not defined what is our lower curve and what is our upper curve. Obviously, the software, when we pick up this set of surfaces, immediately has computed inside what is going to be its upper edge curve and what is going to be the lower edge curve internally. So it knows which area or which curve is the upper curve and which curve is a lower curve. Sometimes, very rarely, you will have an issue where it does this computation a bit wrong. It confuses between upper and lower curve, and sometimes puts the lower curve as an upper curve and upper curve as a lower curve. So you will see that the tool is actually not coming from top, but it's coming from bottom. Okay, nothing to worry. You simply have to select whatever is the curve and go into the tool axis control, and you could swap the curves. Okay, in the event that the software is confused that which is an upper curve and which is a lower curve, you can simply go there and swap the curves, and the result will be perfect again. Okay, let's be back to our guide curve. I am not using the upper curve here. Why? Because you can look at my upper curve. It's not a straight planar curve. It's going up and down. So my tool path also will be the same. It will go up and down. It will follow the upper curve. So I'm going to use the lower curve. The lower curve looks very planar to me, and it's going to follow the lower curve as it is. Then we have the extensions. You could extend it normally or automatically, or you could align it with the edges. That's basically the tool tilt. Or you could start at a particular angle. Okay, this is basically the tilt angle of the tool that you would like to start when you're extending it out. You can use automatic, but in this case the extension doesn't make sense because we are using a closed pocket. Otherwise, you could provide your extension value, especially when you're doing just two surfaces and you would like to extend it out and take the cut further down and then cut again. So the extensions basically are to be used when you're not doing the closed pocket. Let's go to the corners. Again, for people who have already done 3-axis, corners definition is pretty simple. You have either got sharp corner or round corner. Okay. And then you have a relief groove. I'm not sure where people would like to use it, but there are. For example, if somebody is into sheet metal dies and they have a punch holder, basically, where a lot of trimming punches are being assembled. So if you look at a punch holder, and this is something, oops, sorry. Oops, just a moment. I have a problem with my mouse. Okay, perfect. So if I show you how a punch holder looks like, let's say new. So I have this plate here, which is basically like that. Okay. And a plate like that. And then there are several shapes. For example, there's a shape, a rectangular shape, or even some odd shapes like that. Something like that. So wherever you have these corners, okay, wherever there's a corner, because a punch has to sit into that, wherever there's a corner, it's generally a great idea that the tool maker will always provide a relief hole here, okay, so that your sharp corner doesn't interfere with the fitting of the punch into the holder. Now these are called the relief grooves. You can do that relief grooves in swathing itself even if your geometry doesn't have it. Okay, so these are the relief grooves. You can have simple relief grooves. In most of the cases in the tool making world, this is done using simple drills. Okay, but if anybody wants to do that in swathing and they would like to provide a relief groove, then they can do that with swathing itself. Okay, so I'm going to have a sharp corner, and when it's machining the outside area, you can either roll around or provide a sharp corner, especially if you don't want the edges to be damaged, because when you roll around, you actually end up creating a very fine radius on the outer edge. Now, if you still don't want, even if in case of sharp corners, sometimes you still end up getting very fine rounding of the of the edge. If you still don't want that, you can provide a loop. So it will come out completely, make a loop, and then go ahead. It won't damage your edge. Okay. So let's put it, it'll roll around because anyway we are doing an internal cut. In the tool axis, we have introduced two new functionalities, rather one new functionality, not two. We have now two outputs. You can get the output as a 5-axis, or you could get an output as 4-axis. Now, you'd ask me, where are you likely to use a 4-axis swathing? Just imagine a cylinder with a lot of pockets on it. Our wrap function, which we generally use in 2.5D, a similar strategy or similar part can be done using swathing in 4-axis. Okay. Now we are going to introduce another new functionality in 2018, and that is swathing in 3-axis only. So you could now do single line passes in 3-axis purely for prismatic paths, and you could just pass a single line pass all over in 3-axis only. So you will have the output format both 4, 5, and 3. We want 5-axis in this case. Okay. All right, let's go to the link. Let's provide a lead-in and a laid-out. I don't need to do anything else here. I'll just save and I'll calculate it. And you can see that it's pretty quick in the calculation. And if I run the host CAD, this is how it will look like. Now you can see what is happening actually. It's pretty smart. Let's go back again and go into the simulation. Now, let me take a section view. Yeah, that's better. Let's go here. And let's start it. Now you can see what is happening here. The tool has aligned itself in this way. And if I go to the side view, it's aligned in this way. Okay. Now, as it moves forward, notice what is happening. It is trying from this point itself. It knows that the next face is absolutely straight, so it needs to now start aligning itself to the next face by making it straight. So one of the axes becomes straight, but look what is happening to the other axis. The other axis is still remaining at the same angle. It's not changing because it can still tilt in the same axis and machine the other face, which is pretty straight. Okay, but as it moves to the next one, you will see that because my next one is having also a straight angle, it needs to align this tool axis to the straight line. So it becomes straight and then moves further. And as it starts moving further, it is now realizing that this particular face is having a negative angle, so it now needs to start aligning itself to the next face. So it starts moving gradually, trying to align to the next face, and then rolls over that fillet at the corner and moves here. Okay, this looks very nice in host CAD simulation. Okay, let's look what happens on the machine simulation. Okay, let's zoom into this area and let's go one step at a time. And let's reduce this and run it. You can see that there are a lot of rotations, especially when it's trying to do the or move around the fillet. On a very small area, there is a lot of rotation happening, which is not a good sign of getting a good surface quality on the side. So what you can actually do when you encounter such situations where you feel that the rotation is too much and you would like to control how the tool is going to behave in certain areas. Now, this is the most common problem that you will encounter. It's not a problem basically, but it's a common situation that you will encounter. And to avoid the situation, you can actually use the tilt lines method rather than saying automatic, because sometimes, like I said, in automatic, it cannot find the exact 2 points, and when it tries to come close to the result, you will see a lot of rotations happening on the machine. So I'm going to use the tilt lines, and the tilt lines in this case are basically the edges of the surface. So that's one, and then I have the second one. You can simply put another line here in event that you're seeing that the tool is trying to tilt too much. You can put with a sketch, just generate another line here, and it will respect that line. This is number 3. This is number 4. Oops. Reverse. Yes. This is number 5. Number 6. Number 7. And number 8. So you can now control your tilt according to this tilt lines. Now what happens in between this and this is left to the software. It will just interpolate between line 1 and line 2, the tool axis control. But even then, if you would like to control what is happening in between these two lines, you can actually create sketches on this. Even a 3D sketch is good enough for it. You can just join 2 points here, 2 points here, and 2 points here, and create few lines, and the tool will respect that particular lines that are being offered to it. So let's run the calculation. Let's run the simulation on the machine now. It will look much better because the tilting is now controlled by lines, and we won't end up having unnecessary movements. Okay. So you can control your tool axis automatically, or you could control it using tilt lines. Okay. You have another possibility also. You can control the tool axis, or you can synchronize the tool axis using upper and lower curves. In the event you would like to specify manually the upper and lower curves, and you don't want the software to decide those two curves, you can define your upper and lower curve, and the tool axis will try and make the tool axis consistent with those two curves. Okay, so we know that the tilt line works pretty nice. We'll see another thing, and that is in roughing. Sometimes it's not good enough to provide just one single pass. Okay, you need to have more than a single pass. Like I said before, that your tool's cutting length is less than the total height. In that case, single pass is not enough because you don't want your shank to start rubbing and start cutting the surface. So you define the number of slices. So here I can define the depth, or in the depth how many slices I want. I can either define by slices, or I can define by the slice distance. So I'll say I want 3 slices in this case. And what is it, or how should the first and the last slice be? It can morph between the upper curve and the lower curve. Okay, it's actually not a great idea to do that, because in event when you have curves like this, you'll have strange movements on the machine because it's trying to do a 3D on a 5-axis machine. You can step from top, or you could step from bottom. In our case, the bottom looks very nice, but the disadvantage here is that you will have few rapid movements. Well, let's look at the step from bottom, and the direction is going to be along the tool axis. There are several possibilities here. You could say along the contact line of the tool. Okay, that's how it's going to generate the slices. Or if your surface topology is not a straight line. Now this surface topology comes into play when you have a part which is like this, and there is a big radius here. Okay, and you would like to swarf this particular surface using multiple depths. Okay, so there is when you need to use the surface topology. We are going to see a part with surface topology. Okay. In any case, we are going to use it along tool axis. And we are not going to provide more number of cuts radially, but we are going to do multiple cuts axially along the tool axis. We have a possibility that we can also provide radial roughing. That means I can have more than one depth, sidewards depth. I can generate 3 or 4 passes so that the material is removed gradually. It depends on how much material is remaining. In our case, I just want to show you the pattern slices. And in the tool guidance, you can have what we saw in our generic 5-axis. You want to change the cutting edge of, or you would like to change the contact point of the tool every time it takes the depth. For example, let's go here. I have a surface that's like this. So when it is cutting this area, this portion should be in contact, but when it's cutting here, another portion of the tool should be in contact. So we can actually change the contact point of the tool. You could have contact point here, this contact point here, and as it goes down, the contact point will keep changing. This is done actually to use the complete flute length and provide a uniform wear on the surface, and also provide a much accurate surface that's been cut. Otherwise, only your front of the tool is always doing the cutting. Sometimes if it's not a straight line, if there is, let's say, a curved surface like this, only your front of the tool will keep cutting every time you do the multiple passes. So here you can actually provide a axial shift to your tool contact point. All right, let's save and calculate this and look how the result comes up. So you can see that I have got 3 passes and it's going parallel to the lower curve. Now, let's increase the number of passes and see how different it behaves when I provide with a lower curve. As I said, you will have rapid movements once it goes up. You can see that here it is already finished. There's no more area for it to cut, so it is retracted. In such cases, we could provide, instead of step from bottom, we could just say morph and calculate, and you can see that it generates a morph pattern. It moves from the upper curve down all the way to the lower curve. Okay, so you could provide more than one depth of cut and machine the surface. Okay, let's look at another part. And that's, I told you that we're going to see what we call as the surface topology. So I'm now going to add a swarf toolpath. And in this case, the swarf surface is this. Okay. There's no floor because the surface is now open, right? And I'm going to use a 25 diameter end mill. Levels, everything is fine. I'm guiding it at the lower curve, okay? And let's hit save and calculate. Now, see a very funny thing that has happened. What is a funny thing? It realized that this is the best way to put the part and run the simulation, okay? Which is logically perfect because it can also machine this way. Also, it can machine in this way also, but it found that this solution looks more practical for it to machine. So my tool is actually going to come here and this way, and it's just going to pass single line, cut here, and that's it. But that's not the way I want it. I want the tool to actually come from the Z-axis and not from the Y-axis. In such cases, like I told you, that you can end up in very funny situations. You can provide the upper and lower curve so that it realizes what it needs to do. So that's my upper curve. and my lower curve. No. Okay, that's done. Let's calculate. Okay, now you see that it's done it properly because now it knows what you're trying to do with the machining, with Warf. But we have another problem here. The problem here is that in swarfing, okay, it knows that it needs to machine what we call as a ruled surface. A ruled surface has an upper curve and a lower curve, and the surface is formed in between them. So it's like a straight surface. So it will always check the uppermost curve and it will check the lowermost curve and see that it doesn't gouge those two curves. In between that, it doesn't realize what is there unless and until we don't force the software to check or do a gouge check. So I can go here, go into the gouge check. You can see that by default, only the upper and lower curves are checked. So the guide curves are checked. I can say check the swarfing surface, and the options are to degouge, balance, and balance with allowance. So I will use degouge, and let's calculate and see what happens. So it's done the degouging. You can see that it's moved the tool out, and you're going to have a very faint contact out here. Only a point contact will be there. The maximum collision allowed is 0.01, and it's going to keep material here and also material here. Okay. Now sometimes the customer says that I just want the upper line and the lower line and some portion of the surface. I don't care even if you gouge it. Okay. In that case, you can use what we call as a balance. Now in balance, the software tries to find out a right balance between how much it can gouge and how much it can leave from the surface. So if I generate this toolpath, and if I show you the simulation, you will see that it did not gouge completely, neither it left too much of material. So it has run a balancing kind of an act to see that it gouges equally as well as leaves the material equal to the gouge amount. So if it has gouged 2 millimeters here, it's also going to leave 2 millimeters of material. So that's what we call as a balance. Now you could say balance it with an allowance. Okay. Now this is very tricky here because you need to run an estimation of how much excess material you would like to leave and how much gouge allowance. If you get any of these wrong, like in this case, I can say gouge by 1 millimeter and excess material allowed is 5. It will confuse itself because it can't find the solution. Okay. So it will gouge by 1, but it doesn't know whether this is going to be 5. So you have to be very specific on how much you are allowed to gouge and how much you are allowed to keep. So if a customer knows that, okay, I can remove 2 millimeters of material from the surface and this still will be acceptable to me, in that case, you use the balance with allowance and say, you can gouge 2 millimeters and keep whatever is remaining. Okay, so that is about gouge check. Okay, let's use guide curve and let's go back to our roughing and more and provide, let's say 10 passes, now 10 slices, and say step from bottom, and I will say follow the surface topology. Now for surface topology basically means it's going to follow this surface as it is. A very interesting option. So if I run the simulation, you can see that it's cutting again. It's doing multiple cuts at the same time changing the tilt angle. Okay, so it keeps changing, finds the contact and generates the tilt angle based on that contact. So you can machine multiple, you can have multiple passes on curved surfaces. Very important in some cases where people would like to do roughing with large cutters, they can use this method of doing large cuts and follow the tool axis based on the surface topology, and then once the roughing is done, you'll get a lot of steps. You can just do finishing of the part. All right, that's a bit about swarfing. It's not a very complex topic. It's a pretty simple one with very less parameters that you'd like to use for the definition. Another piece of information, in event that swarfing generates still a lot of tools like tilting, and in spite of putting too many tilt lines, it's still not getting corrected. In such cases, you can go to miscellaneous parameters and switch on the custom triangulation, because sometimes we can generate pretty large triangles. Okay, for example, if I want to generate an STL out of this. Okay, so let's edit and save as STL. Okay. Deviation, let's go for fine. Okay, let's say okay and say save. Oops. Why is it not exporting an STL? Sorry. It looks to be a surface data on this. That's the reason. But anyway, if I had to look at how the triangulation would get formed here, I could get one triangle, 2, 3, 4, 5, and sometimes 6 triangles. These triangles are generally not enough in some cases for swarf to find the perfect alignment between the upper curve and the lower curve, the 2 points that it tries to find. It sometimes cannot get the right point. Sometimes it can get one point here, the corresponding point of that would come somewhere here. So the tool axis will tilt that way, and you have absolutely no clue why it is doing that. That is probably because of the triangulation. And what you can do in that case is you can have a much finer triangulation by using the custom triangulation. The only thing that when you use custom triangulation and when you put a particular parameter, okay, and max edge of 1 millimeter, you have to reselect the surface. Okay, put the values and reselect the surface. Only when you reselect the surface, the system computes a new mesh with the new triangulation, and that mesh is sent for calculation. Okay, so if you're not getting good results, you can always go to custom triangulation and provide a very fine mesh to it. It could take slightly more time to compute, but the result will be much better than what it was before. Okay, we're stopping the swarf, and we will enter another area, and this one is what we call as multi-axis roughing. Many times, I have had these requests from customers like, can you do 5-axis eye machining? Well, rather than saying no, you could actually say yes. And you can actually take this part and you can actually show that we really do 5-axis eye machining, although it's not. It's between us that we don't do 5-axis eye machining, but the style of cutting always is similar to eye machining. Okay, so if you would like to scoop out these pockets, now there are several ways to scoop out this pocket. One is you could create several positions and then do 3+2 indexing machining and scoop out the pocket. The other way is to use a technique called as multi-axis roughing. Now, multi-axis roughing as a term itself is slightly deceiving, because we expect that we could give any shape to the software and it will rough out. Actually, no, it doesn't work that way. Multi-axis roughing works on a very simple principle that the side surfaces, the flanks that it needs to cut, should be normal to the floor surface. If it's not normal to the floor surface, then it will leave material from those surfaces. It will not cut the exact surface. So these surfaces, or what we call as a wall surface, should be normal to the floor surface. If it's not normal, then the toolpath will be generated normal to the floor surface, and whatever will be the result will be kept for the side wall. So it could, most of the cases, it always leaves material on the walls. So, like I said, I'm machining style of roughing in 5-axis. So what I have here is a toolpath, and that's called as multi-axis roughing. It's out here. Okay, it's multi-axis roughing. So I have the part out here, and there's only one possibility. And in the strategy, you have got two strategies: offset, which is like our contour roughing. Okay, it just keeps offsetting the profile, or you could use the adaptive. Adaptive is like I'm machining, but it's not I'm machining, like I'm machining. And the strategy we are going to use is to go offset from floor. You have got offset from ceiling. Now, what are the terminologies here? This is the floor, this is a ceiling, and these are our wall surfaces. Okay, floor, ceiling, wall surfaces. So this is the three things that you need to understand. So you have got offset from floor, offset from ceiling, so it will go parallel to the floor or parallel to the ceiling, or you could morph it between the floor and ceiling. In case of our toolpath today, I'm going to go from floor, and my floor surfaces are these 4 surfaces: 1, 2, 3, and 4. And in our wall surfaces, I've just selected all the walls. You can provide them with a different color and select it. There is another possibility that you could select the entire model, including the floor surface as the wall surface. The software is pretty intelligent. It'll understand that the floor has already been selected, and it eliminates the floor surfaces from the wall surfaces and just keeps the wall surfaces which are needed for machining. Okay, so I would like to keep 0.5 stock on the floor and 1 millimeter on the wall. The tool today I'm going to use is a 10 corner radius 2 bullnose with a cutting length of 30 millimeters. And if I go into the levels, again, it's automatic. You can't define anything else other than the entry and exit safety distance. Constraint boundaries is set to automatic, and in the toolpath parameters, we have an option to do the adaptive roughing, and in that case, you need to define the maximum step over. Now, I can tell you a trick on how to do it. If you're using a 10R tool, just create a simple iMachining 2D operation and find out what is the maximum step over it is allowing you and what is the minimum step over it is allowing. So you have got the maximum step over, you have got the minimum step over, and if you are going to do two-way machining, bidirectional, in that case, we have an option here that we could say when you're doing climb, go with 100% step over, but when you're doing conventional, you can actually reduce your step over by the percentage. So you can say, I want only 60% when you're doing the conventional. It's a nice thing, because when you're doing climb, the cutting is very smooth, but when you're doing conventional, it's not smooth. So you would like to reduce the step over in that case. But let's keep 100 for this material. And then you have the adaptive clearance, which is nothing but when it goes into the corner, it cuts and then it needs to lift to come back. So that lift is this value 0.5. Okay, so we are going to have a single slice because that's how iMachining works. And this depth is less than 30 millimeters, and we have got a tool with a 30 millimeter cutting length. In the sorting, like I said, we are going to do zigzag. And the one-way direction is climb, especially when it goes into the corners. In smoothing, if you would like, you can provide a minimum curvature radius if you would like to smoothen it out. And you can filter out. That means you can eliminate areas where you don't want the tool to get in by defining an inscribed circle. So if you have, let's say, a pocket like this, which is open here, and you don't want it to enter into this area, you can provide an inscribed circle radius, and any area that fits into that inscribed circle will not be machined. It will be just eliminated. The tool won't enter into those areas. You have a possibility to define the stock. Okay, the stock could be defined using previous updated stock, or you could define a local stock. I can't use a previous updated stock here because I, first of all, don't have an operation that is not calculated. And secondly, even if I calculate it, I will not have material for my next operation. So what I have done here is I have created a top surface, which is closed. And including the top surface and the side surface, I have defined that as my stock model. Okay, right. And then we provide with the ramp. And when it is linking between groups, I would like it to use ramp because it's going to the retract distance, rapid distance. When it is linking between slices, also I want it to use ramp. And when it is linking between regions, I want to use ramp. But in this case, the only thing that is actually going to use is the last one because it's generating a single pass. So it only will have 4 different regions. So when you have 4 different regions, it will go from one region to the other by ramping. So let's save and calculate it. It'll take about 30-40 seconds. You'll have to bear with me. Okay, calculation is done. Let's come out of here, and you can look that, doesn't this look like an iMachining kind of a style of a toolpath, right? So if I now run the simulation on a machine, and this is actually a very nice part, especially if you're trying to do or trying to show real 5-axis on at an exhibition, and you have a 5-axis machine and you would like to show how we do the cutting. This is a very good part. Customers will just love it. Okay, let's increase it and run. That's the ramping, and you can see that it's doing a pretty nice iMachining style toolpath in full 5-axis. So if I run on the move list, pull it on the side, you can see that all X, Y, Z, A, and C angles are actually moving. Right, it looks really neat. So this part is available on our website. You can actually download it, and maybe you can use a different tool. If anybody has an exhibition and they would like to show real 5-axis, I think this is a great part to show nice 5-axis. You can actually pull a lot of crowd and show them very nice iMachining style toolpath in full 5-axis. Okay, let's stop it here. Another way of cutting it, if you don't want to use iMachining and if you want to use a regular roughing kind of a method, is to use the next method, and that's the offset style. In offset style, it's basically going to generate the periphery here. It's going to find the periphery, and it will just keep collapsing the periphery by the equal to the side step till it doesn't find any more area to machine. So it's simple, like our contour roughing in 3-axis. Nothing else changes here except for the fact that these things disappear now. There's no desired step over and adaptive clearance because we're not doing any adaptive machining. And in this case, in the stock, you really don't need to define because it understands what needs to be machined. So initially, if you want to do a complete area of the part to be roughed out, then you don't need to define stock straight away. But if you're doing a subsequent roughing operation later on, then you need to define the stock. Let's save and run the calculation. By the way, multi-axis roughing is also a great tool for finishing floors of several 5-axis components. You would like to finish a floor of a certain component and you see that you're not getting a right strategy, you can actually depend on multi-axis roughing to do the floor finishing. Okay, because it uses, either you can use the adaptive strategy or you could use the contour strategy, and you can get a very nice floor machined with multi-axis roughing. All right, this also is done here, and this is how my toolpath looks like. You can see that there's a ramp. Okay, when it moves from one to the other, again, it is ramping. So it's machining all of this area here. So you can imagine that you could actually use a single pass of this and actually finish the floor of this particular part. Okay, again, this is a very nice strategy. You can show it at your exhibition. You can show it even to your customers. And if the customer has a similar part like this, he can actually machine or do a roughing with in 5-axis of parts like what I've shown here. I'm coming to the end of my webinar number 6 today, where we today saw Warf and multi-axis roughing. In webinar number 7, we are going to have a week's break next week because number 1, it's a quarter end. Number 2, I'm traveling. So next week is going to be a week where you're going to have a break. In webinar number 7, I will cover the remaining areas of 5-axis. So probably webinar 7 will be the last 5-axis series webinars that we are going to have this time. Once we are done with the 5-axis webinar, we will start with the HSM webinars, which are going to be similar to what we did with 5-axis. All right, if there are questions, you can ask me. I will send the parts of 5 and 6 to Sydney, and he can send those links to everyone, and you can download the part. I will send you the finished parts so that you have some reference, and then you can work on those parts. Right, I see a hand being raised. Just a moment. Let's look at the questions. Oh, there are no questions. Somebody has raised a hand. Okay, Andreas, I'll unmute you, and can you ask me a question? Andreas? Andreas, we cannot hear you. You're very, your voice is very small. Could you type the question? In the event anybody else has questions, you can ask me, or you could put your questions on my email or on my Skype, and I'll try my best to answer them as soon as I can. Okay, Andreas has just asked this question. Let me see. With which service pack I programmed this? Okay, I'm actually currently using a DV version, but let me check. Yes, it's a DV version, but this feature is also available in our SP2HF2 and HF3 that are released here. You can use those versions to machine this part. In the event you have problems with those service pack, just let us know. We will see if the reason is because of the service pack or something else. But I have the same result even with 2017 SP1. Sydney, I'm done, and you can close the session.
Okay, thank you very much, Amo. Again,
well, one moment. Andreas is saying that he can't open the jobs. Andreas, you will need, if you have tried to open my previous path, then you will need the DV version. Get in touch with me on my Skype or my email, and I'll send you the link to download the DV version so you can have the DV version to look at the parts, what I've done.
Okay, again, thank you very much, Ahmad. Again, if anyone has any more questions, feel free to send an email to Ahmad, and he will be happy to answer any of your questions you may have on these subjects. Again, we will not be having a webinar next week, as Ahmad had mentioned, and these parts and the recording will be available on our website as usual later on today. Okay, thank you very much, everyone, and have a phenomenal weekend.